Hi, this is our final team tech video for our last project. This is the Dream Duo. I'm Masheka Lewis.
I'm Annabeth Hrdlicka.
And let's go ahead and go to the first question. If it'll let me. There you go. So in this module or presentation, we're just reviewing what we already had discussed. So for this one, this is from module 1, question 1, part A. And I would like to ask you, why is the 8 so important in the middle?
Okay, so for this type of question, everything has to be a specific way or it won't equal how it's supposed to. So if the 8 isn't in the middle on this one, then the problem cannot be solved correctly. It'll end up with the wrong answer. It has to be set up a certain way, and if it's set up not with 8 in the middle, then only one section will equal 31, which is what it's all supposed to equal, and the other section will equal 34. So if it's not the same, then the whole problem gets thrown off and you'll just get it wrong in the end. So it's really important to remember where each one goes, because if you mess up, then you have to restart.
Thank you.
Of course, thank you.
Oh. Okay, there you go.
Okay, so on this one, you have to consider a new sequence of dot patterns below and complete parts A through C. So we're doing A, and for this one, I have a question for you. So you see these sequences. So how do you find the sequence?
To find the sequence, you'll have to find the distance between each number. Like 1 to 5, you have a 4. 5 to 12, you have a 7, and 12 to 22 is 10. And then you count the distance between those, and you see that it's increasing 3 points each time. So if you just keep increasing the points, the numbers, then you'll get the sequence.
Thank you. That sounds perfect.
I also have a question for you on this. On this part, it said that we have to complete the dot sequence and put them in the right position. So how do you know where to place the dots?
So to know where to place the dots, you have to look at the sequences before it, and you have to look at the original diagram that we were given, and you have to think about the pattern of the dots, and then you have to use your critical thinking skills to think what would make sense to go next, pretty much. So you have to pay attention to the pattern, the sequences, and then just keep going. But the most important part is probably where you do it. So as you can see in the example, it is always important to remember that each time one will be added, it will be on the outside row only. So that is definitely important to remember on this one.
Thank you. You did that wonderfully.
Thank you, of course.
And of course, this is also from module 1, but this is question 5. To do this, we'll have to find out who is married to who.
Okay, it gives us the chart. So on this one, I have a question for you.
Yes?
So we see everything that it gives us on the chart. So how did you use these clues to end up solving the problem in the end?
Well, to solve this problem, it'll be best to use the process of elimination because it says Katie is Will. So we already know one is already married. And then, so we know that Will cannot be married to any other person. And then we just use the process of elimination to eliminate the people that we know for a fact that won't be married to each other. And then we'll finally get the final answer.
Thank you. That's awesome. The chart definitely helps.
Yes, it is best to use a chart when solving this problem.
Yeah, I could not do it without the chart for sure. It'd be all over the place.
Okay, now we're finally heading to module 2. Oh, that's all. So to solve this, we'll have to look at the chart, the diagram, and then remember our to solve for our unions or intersections. I do have a question for you on this one, Annabeth. My question for you
Okay.
is, why is the symbol so important for this question?
Okay,
Because
so for this question, sorry.
no, it's okay.
Okay, so for this question, the symbols are pretty much everything. So you can't solve the problem without the symbols because the symbols pretty much tell you what to do. So not only do you need them to set up the diagram, but like I said, you can't even solve without it to begin with. So the symbols are extremely important. So yes, the symbols show you what to do in this problem. And I have a question as well for you about the symbols.
Thank you.
So what is a union? Because we see these symbols. So what is a union?
Yes, there's just two symbols. You have a union and an intersection. The union is the U, and the intersection is the upside down U. The union, I always think of it as or, and it's all the possibilities in the section. Like B union C is every possibility for the section. So everything in B and everything in C, which would be F, D, H, G.
Thank you. That sounds awesome. That definitely helps to have a trick to remember that as or and then remember the other was as and.
Yeah.
So you can remember it. Having to know the actual complete definition.
Yeah. Oh, and the definitions is up there as a little cheat sheet. So now we're going to, this is still the second module, but I believe this is question 3. And for this question, we'll have to find out the using different numerator system. For this question, we're using Babylonian number system.
I have a question for you on this one.
Yes.
So we don't really know much about this, just Americans, the average person. So how many shapes does the whole Babylonian numeration system have?
Well, right here is a little chart right here for only two symbols or shapes. So the Babylonian numeration system only have 2, which is actually easy to keep track of because we have these boomerang things. They basically like boomerangs. Are 10s, and then the upside down triangle is 1. So it'll be easy to count these. So you only have 2 sections.
Okay, thank you. That definitely makes it way easier. We have millions infinity numbers, so that's definitely easier.
Thank you. And let's go to our next question. Our next question is the process of nines.
Okay.
Oh, sorry.
Okay.
So our process of nines, we'll have to break down the numbers to find out the answer. Oh, our things is in the way. That's still in the way. Okay.
Okay. So I know it's okay.
Okay, I do have a question for you, Annabeth. The question is, would it change the way you work the problem? Would you have a different sign?
Okay, so for adding and subtracting, it doesn't matter. It doesn't have to change. So on this one, it's just subtracting, and on these other ones, you see it's just adding. So if it did have some type of multiplication, division, something else, then it would matter because, you know, that changes it a lot more. But with adding and subtracting, you don't really have to worry about any extra steps. It's just the same basic adding and subtracting we've known our whole lives. So for this one, it does not matter. It doesn't go into PEMDAS at all. So you just have to work with the simple adding and subtracting. So no, short answer, no, does not matter for this one. Long answer, yes, if multiplication or division or some type of other PEMDAS.
Thank you.
Of course.
Now we have the least common multiple, which is from module 3, I believe. And on this, we have to find the prime numbers.
the least.
Okay. I do have a question for you on this one. My question for you is, will it change? Sorry, wrong one. Why are the other numbers not considered a prime number? Like 1, 4, 6? Because these are our prime numbers. Why are the others not considered a prime number?
Okay, so well, for a number to be prime, it needs to have certain requirements, and the main requirement for that is it must have only two factors. And those two factors is that it can only be multiplied by one in itself. So to make it make more sense, I'll say some examples. So 2 and 3 are prime numbers. So 1 times 2 equals 2, 3 times 1 equals 3. But then you look at the number 6, and it would be 2 times 3 equals 6, and 6 times 1 equals 6. So if it can have more than just one in itself, then it will not be a prime number.
Thank you. You did that very well. Like, very well.
I have a question for you as well.
Yeah.
So what are these non-prime numbers called exactly?
They are called corpuscle numbers. Um, they're called corpuscle numbers because they are able to be multiplied by something else to get the number besides one in itself. A prime number, you only can use one in itself to be a prime number, but with corpuscle numbers, you're able to have other numbers like 4, for example. To get 4, you can get 1 and 4, but you can also get 2 and 2, which means it's a corpuscle number, not a prime number. Did I explain it right? Oh.
Hello?
Hello?
Sorry, it got disconnected real quick. But your stuff got staticky, so could you repeat what a non-prime number would be called?
Primary number would be called a corpuscle number. A corpuscle number is a number that is not prime, and a prime number is a number that will be able to be multiplied by one in itself, and that's it. So a corpuscle number is a number that's able to be more than one in itself. Like 4, for example. 4, you can have a 1 times 4 equals 4, but you can also get 2 times 2, which means it's not a prime number. Is everything okay now?
Sorry, your connection went out a little bit.
It went out again?
Yeah, now it's working again.
Okay. So a corpuscle number is a number that'll be able to be multiplied by more than just itself, unlike a prime number. Have 4, for example. 4, you'll be able to multiply by 1 and 4, but also 2 times 2, which makes it a corpuscle number and not a prime number. Hello?
Hello?
Did you understand at that time?
I think so. It's just been like staticky, so could you, like, I heard the last part, but I didn't hear the part where you actually said what the non-prime number is called. Sorry.
It's called a corpuscle number.
Okay, thank you very much. But I did hear how you explained prime numbers, so thank you very much for that explanation as well.
I'm sorry. I have no idea. The process of having it online, it's terrible, I guess. Okay. For this one, I have a. Oh no. I don't have a question for you on this question.
Hello?
Hello? Do you have a question for me on this question?
Okay, now I think it's back on.
This
Okay, now I can see it again.
sucks. I think this is the question. I don't have a question for you on this one.
Okay, I actually do have a question for you on this one. So, how do you know where to move the decimal place, the decimal to make the number into a percentage? And is it the same every time? Do you
To
move
answer
it the
your
same place
question,
every time?
yes, it is the same as every time. To make a decimal into a percentage, you'll have to move the decimal 2 places to the right, and then instead of the decimal, you put a percentage sign. So it'll be like on this example, you'll have a 0.50, but to make it 50%, you'll just move the decimal 2 places over, and then replace the decimal with a percentage sign. So it'll be 50%.
Okay, thank you. That's very good to know that it's the same every time as well.
Yes. Did that go through correctly? Anything?
Yes, ma'am.
Okay.
That freaking fine.
Okay. And this is the one I have a problem with. Question for you. This is problem 4 on our last module. The last module is that we have to put all the fractions and then see the percentage it'll fit into the hexagon. So my question for you is, why is it hard to find the square fraction? Because unlike these, everybody can fit into it with the fraction, but the square don't have a fraction. So my question is, why is it hard to find the square fraction?
Okay, so as we can see, all the other ones fit pretty much perfectly into there, except the square. And the square is the hardest one to find because it does not fit in the shape easily. The square can fully fit 2 times, but any more times it would be overflowing out of the hexagon. This makes the fraction uneven, and then that makes it way more confusing. So that's why there's not even a fraction to begin with. So all the other shapes pretty easy, can fit pretty perfectly. This one, no way. So only 2 times in this for the square. But the easiest ones would probably be the one on the bottom because it fits perfectly half and half. And then the triangles and looks pretty easy as well because it's even. And then all the other ones should be pretty simple as well, just the square because it only fits twice and it overflows.
Thank you. You did that wonderfully.
Thank you so much to you on all of yours.
You did good on all of yours. And that's the end of our presentation for our
Thank you everyone for watching.
Thank you for watching. Sorry about the connection problem.
Happens.
Oh,
Thank you everyone.
thank you for watching.
Bye.